Let's observe a similar pattern for the sample mean x bar when compared to the population mean mu. Suppose we surveyed adults aged 18 to 28 to determine how many hours of sleep they had on a given weekday. Suppose that the entire population consisted of 18,000 adults. And here's a list of all 18,000 entries that have a population mean sleep of 8.001 hours with a standard deviation of 1.51. Let's take a sample of size 25 from this population. And let's note the mean of this sample. Mean is 8.00 with a standard deviation of 1.244. And let's do this maybe a total of 5 times just so we can see what's happening. We can see our distribution that we obtained here. Let's do it again. We did it again and we get a mean of 8.250, a little higher, and standard deviation of 1.548. And we can see here was the first sample mean plotted, and then we have the second one over here. Let's do this a few more times. Another one, we get 8.240 again with a different standard deviation of 1.892. Do it again. Get a different sample of 7.840 with a standard deviation of 1.709. And one more time. So now we have a total of 5 samples here, and they are plotted. Now let's go ahead and take 295 samples. We'll get a total of 300 samples that are going to be plotted down here. Note what the mean of my distribution of sample means is. Is it close to the population mean of the 8.001? Yes, it's very close. It is 8.006. So this would indicate that the sample mean x bar is an unbiased estimator of mu. We're going to talk more about the spread, the standard deviation, in a later lesson. I do, though, want you to notice, though, that as we increase the sample size, the variability decreases, and the center of the graph gets tighter around the sample mean. Thus, this is going to improve our estimate. In fact, let's go ahead and show this. Let's double the sample size to 50. Let me reset everything first, and we'll keep our sample size at 300, and we'll draw the sample. And so we noticed that the mean, again, approximated the population mean of 8.001 very well at 7.996. The standard deviation, though, decreased. We have less variability with a bigger sample size. Something to keep in mind throughout the rest of this course.